Okay, so let's start. Good afternoon. Welcome back to Plan 258. Yeah. So agenda for today, can you see the screen here? So we will discuss about these three things. Yeah? Decision under risk, and then minimum expected opportunity loss, and then decision tree and value information. Yeah. Optionally, you can read this probability tree tutorial with base rule, which is also already in Moodle. Okay. So last meeting we discussed about IFM prioritization, how people make decision. Yeah, this is the classical decision analysis, and then decision under uncertainty. Yeah. Then you have assignment here that you submitted yesterday. Okay, so today we'll have this decision analysis, minimum AL, okay, until here, and then you will have two assignments. Yeah, this one and this one. So two assignments for today. Okay, okay, let's start then. I need to share with you. Can you see my slide? Yes.
Yes, Doc, we can see your slide.
Okay, so this is our first topic. Okay, so decision under risk. Okay. First, we will discuss what is risk and uncertainty, and then what's the difference between decision under uncertainty last time, okay, and decision under risk, and then we discuss about expected value. Okay, so this is the big picture that we discussed last time. We discussed prioritization, and last week we discussed start with decision analysis, which is under certainty and uncertainty. So this is today, okay, decision under risk, and then maybe this is next week, and okay, so decision under utility, group decision making, and then game theory. Yeah, this is game theory represent decision under conflict. Okay, so let's start with the first part. Okay, so what is risk and what is uncertainty? Okay, so uncertainty refer to not knowing, okay, what will happen in the future. Okay, so in this case, you have little or no data available, okay, or it is too expensive or time consuming to get the data. So not even probability information you have. That is called uncertainty. Okay, and what is risk? Okay, risk is similar to uncertainty. Okay, so it is associated, it is uncertainty with associated undesirable outcome. So for example, financial loss, damage, death, and so on, as a result of course, of action or inaction. Okay, but okay, we have good probability information. So what make it different is actually the probability information, good probability information. So if you don't have it, so this is practically under uncertainty. Okay, so last meeting we discussed about decision under uncertainty. Okay, these are the characteristics of decision under uncertainty. First, it is a single person decision making problem. Okay, it's not group decision; it's just one person. Okay, you, and then the probability distribution of the state of nature is unknown. So you don't know the probability of state of nature. And then the decisions are based on criterion. These are the 5 criterion we discussed last meeting. And then there is a range between optimistic to pessimistic or somewhere in between. Okay. And then you can use either gain payoff or cost payoff matrix. Okay. So since you already have the assignment, so I think this is very familiar. Okay. So what we will discuss today is called decision under risk. Okay. It's the same. This is single person decision making problem, but okay, what make it different is the probability distribution of the occurrence of each state of nature is now known. Okay, this is called subjective probability or sometimes called base probability. Okay, because it's based on opinion, so you can set the probability based on your own opinion. Okay, so the criterion is simplified. Instead of so many criterion, okay, we use expected value. Okay, or later we'll discuss. We can use also expected opportunity loss. Okay, so the probability of occurrence of the state of nature are the same for all alternatives. You see here, okay, we have probability information only in the state of nature. Okay, but we don't have probability of occurrence in the alternative. Yeah? But we can release this assumption when we discuss in the next slide, which is about decision tree. So, yeah, so first let's discuss how are we going to quantify the risk, right? So risks are measured in finance. Okay, usually as standard deviation of the outcomes. Okay, but standard deviations tend to be very large number, positive or zero. Okay, very large number. So then we cannot understand what is the meaning of this. Yeah, we only know the larger mean higher risk. Okay, so then people start to create a relative value. Okay, so how to create relative value? Either the standard deviation divided by the mean, okay, or the mean divided by the standard deviation. Yeah, so in robust statistic, so we don't use standard deviation. Sometimes we use what is called interquartile range, and then the mean is replaced by median. So, but the point is the same. Yeah, you have interquartile mean, quantile range, IQR, divided by the median or the other way around. Okay, so in finance, okay, in trading, you probably learn about SURP ratio is basically coefficient of variation. So when we create decision making, decision analysis, so we use this kind of table. Okay, so we have n state of nature on each column. Okay, and then we have alternative m alternative as the row. Okay, so to simplify, we use payoff gain. Yeah, of course, you can also use cost if you want. Okay, so this is the gain value. So this is basically the payoff. Okay, so then how are we going to compute? Okay, we use what is called expected value. Okay, in the past, we call this expected monetary value, EMV. Okay, but now mostly we use expected value or EV. Okay, so they are the same thing. So this is an approach to select decision alternative, okay, that is based on expected value on each decision alternative. Okay, so we find the best expected value. Okay, the best expected value depends on the actual payoff matrix, whether it is gain or cost. So the best can be maximized or minimized. Okay, but there's a very big assumption here. Okay, that the alternative that you put must be uncorrelated. Okay, so if you violate this assumption, so the method will not work. Okay, so what is expected value or expected monetary value? Okay, so you are already familiar with Laplace criterion last meeting. Okay, exactly the same formula. Okay, so expected value. Yeah, so we put it gain average here, yeah, of the column J. Oh, no, this is not column. This is a row. Of row J, yeah, is the probability of the column. K is the column. And then G here is the gain, right? Row is J, K is column. So, and then we sum across all the columns. Okay. So EMV is the payoff of the first state of nature multiplied by the probability of the state of nature plus the payoff of the second state of nature multiplied by the probability of the second state of nature and so on until the last. Okay. So that's the meaning of EV or EMV. So exactly this formula. And then how do you make decision? Yeah. If this is gain table, then you just take the max. Yeah. When we say max, that means the maximum of this value across the row. Yeah. J in here is the row, so across the row. If it is cost table, so you just take the mean. Okay. So as example, we use exactly the same values as last meeting. Yeah, it is the same thing. The number you already typed in your Excel last week. Okay. So what is the decision? Is the payoff matrix is given below. Okay. So we have state of nature N1, N2, N3. And what's the make it different is actually this value. Yeah. Probability with is given. Okay. Of course, the sum of probability must be 1. Okay. So how are we going to compute? Easy, yeah. So we get the probability. So and then you multiply this probability. So sum product this probability with its row. Okay, so you will get the EV. Yeah. Okay. So this one 6.6 come from 0.5 multiplied by 5 plus 0.2 multiplied by 7 plus 0.3 multiplied by 9. Okay. Because this is a gain table, right? So, and then we take the maximum. Yeah. The maximum is 6.6. Then the decision is the argmax, which is A. Okay. So you can compare to Laplace. Okay. Criterion last meeting under decision under uncertainty. Okay. So in that case, what's make them different? The one that make it different is actually the probability. In Laplace criterion, we assume equal, 1/3, 1/3, 1/3. So in here, you make a different assumption here on the probability. Okay, so here I finish. So easy. Any question?
So a question regarding the probability. You said it is given for this EMB. My question is it subjective or subjective probability or
Subjective. The probability is subjective. So we
all right, okay.
bias. Yeah. So bias probability you can search in Google. Okay. BY
Bias.
bias probability. Yeah. So practically this is based on opinion. Okay. So this probability is subjective. So you decide. Okay. And then you can revise Bayes theorem. When we discuss Bayes theorem, okay, there is possibility that you will revise the probability based on the fact. Okay, first you set any numbers. When the new fact come in, and then you can revise your opinion. Okay, so this is what is called base probability. Okay. Later during decision tree, we'll discuss how we'll decide the probability. Okay. So at this point, let's assume you just decide on your own subjectively. Okay. So next, is this fair game or not? So the game is fair. Okay. Is the EV or the expected monetary value are 0? Okay. So suppose there's a game. Okay. It's a quite gambling game. If you join, okay, you need to pay $20 to join the game. Okay, but the probability is no. So 20% of winning 100, okay, and then 30% of winning 50, and 50% winning nothing, 0. So the question is simple: is this a fair game or not? You will join or not? What do you think? Can you
I will
calculate
join.
the EV?
I will join, sir. I will join, sir.
You will join, right? Why?
Unfair,
Why
sir.
you will join?
Because there's a 50% chance you can win both either 50 or 100. The another 50 is 0. Yeah.
Okay, the way to compute is actually compute the EV or the EMV. Okay, so every time you deal with gambling, okay, try to compute the EV. So there is a 20% chance, right? You will win 100. 30% chance you will win 50. And then 50% chance you win 0. So you just sum of this probability, okay, you get 35. But to join, you only need to pay 20. Okay, so if you play long run, so this is kind of lotto, right? So if you play in the wrong run, okay, you will win 15, right? 35 minus 20. So yes, the game is unfair, but not unfair to you. It's unfair to the person who play the game, the one who hosts the game. Yes, the EMV is 35 larger than. Very good. Okay, so you can use the same technique, okay, to check your own lotto. Okay, can you calculate what is the EMV of that lotto? Okay, and whether it is fair game or not. Okay, clearly not fair, but have you ever tried to calculate? You can calculate the probability based on the games. So next one is next practice is interesting. Yeah, this is proposed by Blaise Pascal, a well-known scientist, 17th, 18th centuries. Okay, so this is very well-known decision example, yeah, decision analysis called Pascal wager. Okay, so there is a probability that God exists, which is not 0. Yeah, so we don't know the probability. We just know that this is not 0. Okay, and then the non-existence of God has a negative payoff. Yeah, say minus z. Yeah, we don't need to value this minus z here. If you believe, okay, and then God does not exist, you practically waste of time, waste of energy, waste of loyalty. So there's a value of minus z here. Okay, but non-believer, okay, in case of God exists, okay, will have infinite negative payoff, right? So eternal damnation or hell. So here, okay, so infinite negative infinity. Okay, so and then this x and y are just any positive finite payoff. Okay, so question: can you compute the EMV? The alternative is whether you believe or not believe. Okay, the state of nature is the existence or non-existence of God. Interesting enough. So, what will be the conclusion? Oh, we don't know the number. Well, we can put any number, no problem. Okay. Can you try? Yeah, we can just use algebra actually. Okay. So what is the EV of belief? Okay, so we know the probability of God exists is P here, right? So that means the probability of God does not exist is 1 minus P, correct? So in that case, you multiply, yeah, P multiplied by X, and then 1 minus P multiplied by minus Z. Okay, so, and then the second part is P multiplied by negative infinity, and then 1 minus P multiplied by Y. Okay, so the result is well, okay, so the first part can be positive or negative. Okay, the first part here depending on the value of X and Z. Okay, not necessarily positive. Yeah, this one. P multiplied by X and then 1 minus P multiplied by minus Z is not necessarily positive, can be negative, depending on the value of X and Z. Okay, but the second part here is interesting. Whenever people start to deal with infinity, okay, that become interesting. Yeah. So negative infinity represent eternal, yeah, damnation or hell. Okay. Positive infinity represent heaven or God. Yes. So in that case, if you compare, okay, whether you need to believe or this is the possibility, right? Believe or non-belief, okay, then of course this one is negative infinity, yeah, compared to even this is negative, okay, this is compared to this one, this is actually always lower, okay. So in that case, regardless how small the assumption of even the probability of God existence is super small, okay, but still positive, then it is better to believe than not to believe. Okay? Logically, this is based on logic. Okay. So next one, is this your assignment? No, not yet. Okay. So suppose you, okay, Ali is an investor. He can invest in his $100. So you can just put any number here, but say you have $100. Okay, you have two choices. Okay, you want to buy government bond. Okay, so if you buy bond, okay, so then what you will get 10%, yeah, 10% return in 1 year, yeah, or you can buy stock, yeah. So if you buy the stock, okay, so then you can have 20% return. Wow. Okay, 20% return. This is the benefit. Okay, but there is also possibility that zero or zero or zero. Okay, so the question is, should we invest in stock or bond? Oh, is there any probability information here? Okay, so we don't know. Then
Get the performance. You don't
uh,
like the probability.
the probability is the one that you want to find.
So is it 50-50?
50-50, yeah. Good or bad. Performance good, zero
Mhm.
return.
Okay, so
20. Zero.
correct. So you need to find the probability because we don't know the probability. So let's define probability as P. Okay, so there. So let's define the probability as P, that say this is the probability of good state of nature. Okay, so let's say this is P here. So then because there are only two, then this one is 1 minus P, right? Okay, so we use the same 1 year period. So the EMV of bond, okay, you invest 100, so you will get 110, right? So then you get this. We don't know the P, but because this formula, P, and then this one also the same 1 minus P, so this one will remove each other, so it's still 110, right? But in here, we don't know. Okay, so this is 20%. Okay, and then you did not earn anything, 100. So in that case, this part contain P, right? So in that case, you want to check what is the value of P. So then you get P is equal half. So that means if the probability is larger than half, you select the stock. Okay, if the probability is less than half, you select the bond. Yeah, that's exactly what people are doing. Okay, that's why for this time they pull out the money from the stock exchange, for example. Yeah, because based on this kind of probability. Okay, so this is very useful method. Yeah. So this is the next practice is your assignment. Okay. Yeah. So suppose you have 10,000. Okay. Suppose you have 10,000. Okay. And then if you put in the bank, you will get 3% interest. Okay. No risk, right? So you put into time deposit. Oh, this is not time deposit. Yeah, time deposit in the Philippines very, very small, isn't it? Not even 3%, less than 1%. Yeah. But let's say this is very generous bank, give you 3%, no risk. Yeah. In Indonesia, the interest rate is actually 5%. So if you invest your money in stock market, okay, of a venture business, say a startup, you get 7%, yeah, on average. But there is also probability that you lost all your money. Okay, 10% risk. Oh, should you invest or in the bank or put in the stock market? Okay, so it's very tough decision. Okay, so depending on the perspective, whether you do it, you play it per year, short term or long term. Okay, so let me get the Excel. So okay, this is what you will do for your assignment. Okay. You put 10,000 here, okay, and then these are the numbers that we just discussed. Yeah, 3%, 7%, 10%. Okay, there. This is 10%. This is 3%, 7%. So the probability of bank interest is 100%, right? And then the stock interest of 7% is 90%, basically, because you have only 10% risk. So that means only 90% no risk. Yeah, in this example. Then there is a risk you lost everything. Yeah, -1 multiplied by the value. So this one is easy. Let me show the. Let me find the Excel file so that I can show to you. Oh, is this the one? This one, probably this one. No, not this. Where is? Oh, this one. Yes. Can you see the Excel file?
Yes, sir.
Yes. So here I just copy from here. Okay. And then here, because you said 3%, so you just this previously plus the bank interest. Okay, so this is basically the previous value. This is the year, right? Plus the interest. The interest is previous value multiplied by the bank interest. So the bank interest does not change, so we put the dollar sign here. Okay. And then in terms of the stocks, okay, so this is the same thing, yeah. So you can just put the probability, okay, of this value. Now, in terms of the stock, you have 90%, okay, and 0.1%, right? So total is 100%. So in here, you get the stocks value, okay, and in here again, you use this one multiplied by that, yeah. So what is the actual stock value? Stock value is the same here, 7%, yeah. I just multiply 7% here, interest, okay. So this is exactly 7%. So, and then in here, we lost everything, yeah. We lost this one, everything, okay. But don't forget, even if you lost everything, we still multiply by the probability of lost everything. Okay, and then of course this one is just sum, yeah, these two. Okay, so then this is the actual value that you compare. Okay, this one and this one you compare, you put it into charts like this. Okay, so this one and that one. Yeah. So then you compare which one is larger, right? So if this is larger, you put this is larger, then you put bank. If this is larger, you put stock. So then you can start to see here, okay, if you are in the short term, okay, you probably want to put with the 100%. Yeah, the bank is better. Okay, yeah, on the top here, the bank is better. Okay, but in the long run, okay, if this is continue, so the stock is actually better. Yeah, after how many years? 6 years. Yeah, in the 6th year, you start to gain better than. So, is there any question? This is your assignment. Okay. Yeah, so the next one is this one, yeah. So the next slide. This one. Can you see the slide? No, this is not the assignment. Yeah, the assignment is the previous one. Yeah. Last year I gave this as assignment. Okay, suppose you have now 100,000, okay, dollar, and then you put in the bank, you get again 3% interest, no risk. Okay, what is the difference now is now you have actually probability distribution, not just two numbers. Now you have risk profile. So later we'll discuss about risk profile. Okay, so you have a risk profile here that the probability is if you invest your money in the stock market, yeah, you will get 7% interest with 50% probability. Okay, but also risk only to get only 5% with 10% probability. You earn 3% with probability of 20%, and then 1% with the probability of 10%, and then you may also lose your money with the probability of 10%. Okay, of course, the total probability must be 1. Okay, so then you can compute also the same technique, yeah. So compute the EV for both alternative, okay, and then based on the EV, are you going to invest or put in the bank? So the same technique, yeah. So the difference is now the bank is still the same, okay, but now you put all these probability values here. Yeah, these are the actual gain, and these are the probability, okay, and then you compute. Yeah, one by one, I will show you the Excel. Can you see Excel? So this one is P course. So this is the bank interest. This is the actual money you put. Okay, everything in yellow are type. Just type this. Okay, and this one, this is the principal 100,000. So I put P. Okay, and this one is based on the previous value. Okay, and then multiply by this gain percentage, multiply by the previous value. Yeah, the same thing here. So if you take this is the previous value multiplied by this gain interest. Okay, and then the same thing. Okay, here the principal. Okay, and then this one also depending on this percentage. Okay, because this is loss 100%, so you just put all. Okay, and then to calculate the stocks, you need to do some product. Okay, so the probability multiplied by this one. Okay, and then of course your decision now if which one is larger between the two. Okay, then in this example longer, you will see that the stock starting to be better than the bank after 9 years. So I hope this is clear. Okay, when you use the decision under risk, okay, you practically need to have what is called probability information, and not just one or two values probability. You practically can have the whole risk profile, yeah, the whole probability like this, okay, including the loss. Then you can start to compare. Okay, up to here, is there any question? Yeah. So this is nice, okay, simple and nice, okay, but there is a problem, yeah. EV does not cannot explain the seemingly irrational behavior. Yeah. You know lottery, right? I think lotto in the Philippines is very big. Right? So the risk is actually higher and the probability is very small, but the gain is very big. Okay. And if you calculate the EV, everyone knows this is, yeah, float is like, I don't know. So if you calculate the EV, okay, actually losing, but people still buy. That's strange. Okay, so actually we can, the economists already come up with what is called utility theory. Yeah. So next time, next week, we will discuss about this. Okay. So we can still incorporate decision maker attitude toward risk. Yeah. By solving what is called utility analysis. Yeah. So this is just the point about this. So about decision under risk, is there any question? If not, I will just close this one. Close this one later. No question at all? Are you sure? Premium. EV by insurance premium. Yes, we will discuss after utility, okay, about the premium. Now you can check also in the slide there. Yeah, the insurance premium we can discuss. Yeah. Okay. So yes, EV can be used by insurance premium. We have next week. Yeah, we will talk about the premium of insurance. Okay. Today, let's focus on decision under risk, decision 3, and base theorems, yeah, probability 3. Okay, so in that case, let's go to the next slide. Yeah, it's also short, which is called minimum expected opportunity loss. Yeah, EOL, yeah, expected opportunity loss. So this is still decision under risk, yeah. But instead of using EV, expected value, yeah, which is, of course, if it is gain, so you want to maximize. So we use regret. You remember, you computed regret during decision under uncertainty. So those are the basic. Okay. So then we will use that technique of Savage minimax regret. Okay, and then we adopt that value, the same formula. Okay, and we use it here. Okay, so let's talk about opportunity loss or regret again, so that you can be refreshed. Okay, and then we compute, yeah, similar to EV, this is EOL, yeah, expected opportunity loss. And then, of course, because this is loss, so you want to minimize, right? And then I will introduce you with the information. Okay. At this point, let's play fortune teller. So perfect information. Yeah. So we call this EVPI. Yeah. Expected value of perfect information. So this is the beginning. Okay, so what is minimizing EOL? Yeah. So alternative approach, yeah, to maximizing EMV is minimizing EOL. Exactly the same decision you can produce. Okay, so minimum EOL will produce the same exact decision as maximum EMV. Okay, so both are decision under risk because there is also probability distribution. Okay, so what is opportunity loss or regret? Okay, so regret can be computed as or defined as the absolute difference between the actual payoff and the optimum payoff. Okay, so this is the optimum payoff, so maximum gain over all the columns, or minimum cost over all the columns. Yeah, so this is optimum payoff, and then you take the difference. Okay, so absolute difference, that means you reverse, so that regret is always positive. Okay, so this is the amount of loss by not picking the best alternative. Okay, so then what is expected opportunity loss or expected regret? Yeah, EOL or expected opportunity loss is just like that. So you have the probability information and then you multiply by the regret. Okay, so this is represent the loss, right? LJ. Yeah, remember the probability is in the columns, yeah, because this is the state of nature, and the regret is J, K. J is the row, K is the columns. Okay, and then you sum over all the columns. Yeah, so in the same row. Okay, and then you will get because this is loss, so you minimize. Okay, and then you get the argument of that minimum. Okay, that value is the decision, right? So across J in here is the rows. So let's use the same value, okay, but we change the probability. Okay, so the same value last week and a while ago in decision under risk with expected value. Okay, so we change the value of probability now. Okay. Remember, total probability is always 1, yeah? So 80, 15, 5, that is 101. Okay, so let's compute the regret. Okay, so if you compute the regret, okay, what you will do, you get the maximum in each column, right? So this one, 5, 10, and 20, so 20, yeah, so you put there all the same. Yeah, 7, 5, and 3, the maximum is 7, so you put here all 7, okay, in the same column. 9, 0, and negative 15, so 9, it's the maximum, so you put there. Yeah, this is called maximum payoff, yeah, for each state of nature. Okay, then you calculate the regret. Okay, so the regret is just the difference, right? So this 20 minus 5, you get 15, yeah. This 9 minus 9, you get 0. Yeah, this is exactly the same slide last week in decision under uncertainty using Savage minimax regret. Okay, so you already know this. Okay, once you, but in Savage you do minimax, but now you using decision under risk, okay, because you have probability information, you don't do minimax. Okay, what you do is minimum EOL. Yeah, so you multiply this probability with the value. So this is some product, okay, of this probability and its row. Okay, so say the third row here. So you have 0 multiplied by 0.8 plus 4 multiplied by 0.15 plus 24 multiplied by 0.05. So you get 1.8. Okay, so the same thing here. Okay, this value you multiply by this probability, you get this value, EOL. Okay, L. Okay, so then because this is loss, so you minimize. Okay, so the minimum is C. So this is the now this is the minimum. So the arc mean is here. Yeah. So the decision is C. Yeah, so I put here decision. Clear or not? You see, yeah? Yeah. So first you calculate the regret. Okay, so this is the regret. Okay. So once you get the regret, you don't do minimax like decision and the uncertainty. Why? Because you have the information about probability. So you use this information. Okay. Better decision. Okay. Okay. So can you practice this one? So okay. I do exactly the same. Okay. All you need to do is just change this probability. Okay. Can you make it? Anyone want to share? I will set you as co-host also so that you can share. Okay. Anyone want to share screen? Go ahead. Yeah. Rafi, you can share your screen. and Vin. Oh, the value is 6, 8, 0.5, 0.2, 0.3, and then you need to calculate the regret first, Rafi.
Yes, sir.
This is still the original. This is not the EOL. Okay. Okay, Win, we want to share?
Okay, let me. Okay, is my spreadsheet showing already?
Yes, yes.
Okay,
Good.
here's the given.
Yes.
And then as per original, it's as the same as what Rafi has shown earlier. So getting the EMV, then getting the max EMV. But for the regret, we take the maximum of each column or state of nature, then subtract the corresponding gain or payoff
Yeah.
gain that cell. We do that per column. We get this regret matrix. Then for the EOL, it's just the sum product of the probability and the regret
Very
per
good.
row.
So
Okay,
you.
so, I'll have a question on this one.
Uh-huh.
So this one is the example on the stock.
Okay, a while ago.
Just the bank. Yes. I have trouble understanding this one.
Oh.
Whether how you put the values on the
Initially, you need to put 100,000. Yeah.
yes. Here.
Yes. The same. To be the same, right?
Mhm.
And then you're supposed to have you may lose everything.
The gains you get from the stock.
No. This is 100% loss.
Okay.
Let me find that. Oh, I already did it. Let me find yes. So you're supposed to lose everything. So the second row is minus 100,000, right? And then the second row is minus 100,000.
Mhm.
The previous.
That would be 0.
No, minus.
Okay.
Actually, you can just multiply. The same formula actually using this. How do you use the formula in G55?
G55.
What is the formula in your G55? First year. Oh, I don't use that. So I just use, oh no. Okay. So you can, actually you don't need to do that. You can just use difference equation, right?
Using this one.
And then plus, right? Okay,
Okay.
plus that one, correct. Okay, good. Okay, then
Okay.
that one you can drag all up to the right also, to 100,000. No. To the second column, third column, and so on, until the last column, K. No, the first value is not. The first value is not correct because the first value is supposed to be the principal, which is 100,000, right? Okay, so
Until here.
continue, yes. Why? Oh, first one, oh, okay, sorry. The first column like this is negative of the previous value. Negative of that D54.
Okay, so this one.
Okay. And then this one is negative of the next one, the next value, yes, 85,000.
Okay.
Why I get different value? Why you get 85? Where this 85 come from?
Sir, should I take the negative of the preceding row? This
Huh?
one?
Yeah, that's okay also. The same.
And then bring it down.
Oh no. Supposed to be no. Supposed to be the negative of this value in this D.
Okay.
The one that you get in the stock, the previous value, you're supposed to lose everything. No, you just copy. You just use one cell and then copy down the same.
I got
Right.
And then
And then yes. And then the
So now-
stock. Yes. In the how many year?
year 6, sir.
Year 6, yeah, probably by computation. So can I see D55? D55 or 57?
Year
What?
55.
D in your column. Okay.
Good.
Okay. That one is fine. Yes. Okay. Good. Yeah. So you may lose everything that is previous year, isn't it?
Mm-hmm. Based on club.
Oh. So then you get 6 year.
Sort of, sir, but not exactly year 6.
Okay, 7 years.
Yeah.
Yeah. Okay. Good.
Okay. Thank you, sir.
Right. So anyone else want to share screen? One more. Okay, Rafi, you corrected already, so you want to show? Oh, Kenneth, you also want to show? You want to show? It's the same thing, right? Like Vin. Is there any question here? Minimizing expected opportunity loss. Okay, the same thing. So now, if you don't have a question, I have a question. Okay, can you compare the minimizing EOL, okay, so expected opportunity loss, with the previous slide about Savage minimax regret rule? Okay, my question, can you get the same decision or not? Then why you can get or why you cannot get the same decision? And then what is the implicit assumption of Savage minimax regret? Okay, is that assume equal probability or actually something else? So you can try probability uniform probably. Will you get actually Savage minimax regret or not? If not, so what is the actual probability? Okay. The same number, right? Last time what you get? Last time what you get for Savage? And then this time, what do you get? So you have different decision, isn't it? So then if they are different decision, then you ask why. Okay, why they are different? All right. So, is there any answer for that? The same number last time. Okay, the savage minimax regret will decide B. Right? But this time you get A in practice 2, and then in practice 1 you get C. Okay, what I do change in practice 1 and 2, okay, is actually only the probability distribution. So, okay, in that case, what is the probability distribution? You can play with that numbers in order to get B. So that the same as savage minimax regret. It is yeah, based on EOL, okay, you are either A or C, but you never get B. But in savage minimax regret, you get B, isn't it? So my question, can you change the probability, okay, in order to get B? Yeah, this is just out of curiosity, yeah, but this is quite interesting. Okay, so let me share with you my slide. So here is the previous slide on savage minimax regret. You see? Okay. So you get this other regret, right? The same regret anyway, right? So the same regret table. So you have 15, 10, and 24 by the maximum, and then you minimize that, right? So you get P with this minimum, savage minimax regret, you get P. Okay. So now I want to show in minimizing AOL, okay, you get exactly the same regret table, this one, okay, but instead of minimax, okay, now you get probability, yeah, so you multiply with the probability. What is yes? Yes mean what?
You can change the probability, sir.
Yes, you can change probability, but can you get B?
Yes, sir.
The alteration, sir. You change the probability.
The probability from N2 and N3, sir.
Okay. Can you share screen then?
Yes, sir. For a while. Sir, can you see my screen, sir?
Yes, I can see your screen. Where is your probability?
My probability, sir,
This one,
the
0.5.
interchange. Yes, sir. Originally, the N2 probability, sir, is 0.2
Okay.
of 20%, and then the N3 is 30%, then I interchange it, sir. So I
Okay.
got the 7.4 EUL.
Okay. Good. Good.
So it is on the alternative B, sir.
Oh, okay. So now, can you compare this EOL, okay, with the maximum EMV with the same probability? Will the decision the same or not?
No, sir.
The same probability, oh.
Okay, sir.
I mean, from the original value of the gain, yeah, supposed to get the same decision. Can you check? Okay. The race is finished. Okay. Anyone check that? Comparing EOL and EMV? Yeah. You're supposed to get exactly the same result, yeah. Not the same value, yeah, but the same result of decision. Yeah. Okay. So the minimum AOL is supposed to get the same decision alternative as maximum EV. Okay. Okay. So now I want to share with you the. Suppose now you have a fortune teller. Okay. Suppose now you have a fortune teller. Excellent fortune teller. Okay. That can give you perfect information about. Yeah, this is called perfect information. What is perfect information? Perfect information means you know with certainty, wow, 100% correct, okay, that in advance, okay, that certain events will occur. Yeah. Or tomorrow that stock will go up how much? So perfect information. Yeah. So if you know perfect information, okay, so how rich you can be, right? Okay, so what is perfect information is knowing with certainty in advance, okay, what events will occur. And that's the definition of perfect information. So of course, perfect information about the true outcomes of uncertain value in the future event is very rarely available. Okay. So however, okay, this knowing this idea maximum is actually worth knowing. Why? Because once you know this, okay, you will know how much are you willing to pay for some kind of information. Do you understand? We are talking about WTP here, willingness to pay. Okay, so for example, why are you hiring a consultant? Okay. Why are you doing feasibility study? Why are you doing experiments or simulation? Okay. So all of these are basically you want to get in advance, okay, of certain information that what will happen. Okay, they are not perfect, okay, but in order to compute, in order to understand the imperfect information, you need to understand first what is perfect information. Okay, so once you understand the perfect information, then you can shift your thinking into the real world with this imperfect information. Okay, let's start that. Okay. That's the whole idea. Later when we discuss about the value of information. So how are you going to value the information? Okay, so at this point, let's assume perfect information available. Okay, and how are we going to calculate that? Okay, so here is what is called value without information. So let's call this I0. I represent the information. Okay, 0 means no information. So the maximum expected value a while ago, the EMV, okay, this is basically exactly the same as information, okay, is a value without any information about the state of nature that it will happen or not. Okay. Yes, you have the state of nature, this probability value, okay, but you don't know which one, right? You don't know which one will happen. So this is exactly what we already computed. Okay, so this is called value, okay, without information. So I0. So let's give you example, okay, so that you get reminded again. So I have this the same table, okay, and this is the probability information. Okay, so can you compute expected value without perfect information from this table? So that's easy. Okay, what you will do is just maximizing the EMV. Okay, you might confuse. We already discussed this. Why you change the name? Okay, why you change the name now become expected value without perfect information? Because now later we will have another information. Okay, this is without, meaning later we will calculate with perfect information. Okay, so without perfect information, this is just exactly the same as maximum EMV, decision under risk a while ago. Up to here, is it clear or not? Just name, change the name, and the value is still the same. Yeah. So next one, okay, you will compute what is called the value with perfect information. Oh, what's the difference? Okay, so that you can compare. Okay, here is the difference. This is the same as maximum regret a while ago. What you will do, you maximize the gain first for each row. So if we have the perfect information on which state of nature will occur, then for each state of nature, we will select the alternative that will yield the maximum payoff. Right? So in that case, okay, what you will do is you maximize this first, and then you again multiply by the probability. So a while ago we call it I0, now we call it I1. Okay, so what's the difference? Okay, let's compute that. Okay, we use the same exact the same number. Okay, how do you compute? The same like maximum regret a while ago. So we get the maximum in each column. Okay, you get the maximum in each column. Okay, and then now this is what you will do. Okay, now you use this probability multiplied by the maximum in each column. Easy or not? Okay, do I confuse you? So, okay, you multiply this 0.5 with 20, yeah, 0.2 with 7, and then 0.3 with 9. So that the result is this one, yeah. Because they are the same, so of course the value is all the same, yeah. So this is called I1. Up to here, is it clear or not? So you have I0. What is I0 again? Okay, you have I0, this one, yeah. This is maximum EMV, which is the expected value without perfect information. That means you don't have any information which one is the correct one. Okay, so what is the value? 6.6, yeah. In this example, 6.6. And then now we have expected value with perfect information. The value is 14.1. So what is that for? V minus. Okay, this is what we call it as EVPI. Okay, so what is that? Expected value of perfect information. Yeah, which is the absolute difference, okay, between I1 and I0. Okay, so EVPI, okay, you subtract the value of alternative with perfect information, I1, from the value of without perfect information, which is I0. Okay. Oh, easy, right? I1 a while ago, what we get? This one, 14.1, yeah, 14.1. What is I0 a while ago? 6.6. Oh, what is the delta I? Yeah, the delta S is the EVPI. Yeah, it's just minus that. So you get 7.5. So what's the meaning of this 7.5? This is dollar, yeah? So this is actually the willingness to pay. Okay? So this is the willingness to pay for the fortune teller. Okay? If you have a perfect fortune teller that will tell you what will happen, okay? This is the maximum amount that you are willing to pay based on that table, yeah? So it is only $7.5. So this is the maximum amount of consulting fee, okay? If you can get the perfect information. So any amount bigger than this is a corruption, right? So this is theoretical value already. So you will not use this, but this is the theoretical value. Okay. In fact, okay, this is interesting. Why? Why this is interesting? Because this one is actually the same as minimum EOL. Wow. Interesting or not? Yeah. This is actually the same as the minimum. So the EVPL is actually the same as minimum EOL. So I'm trying to connect the dot here. So up to here, any question or not? Is there any question? Is this difficult for you or? Because the next one is much harder than this. We will repeat this again, no problem. Okay, in the next slide, we will repeat this again, and then we will go to the EVSI, which is expected value of sample information, which is the reality. Okay, so at this point, perfect information is theoretical value. Okay, so you just remember here, okay, what I want to say is, look, the minimum EOL is actually the same as EVPI. A lot of jargon that you need to remember, I understand that. Okay. Okay, so up to here, is there any question first before we go to the next slide? Or you want to practice? Do you need time to compute this? No, right? I think this is your table a while ago. When you compute the regret, remember you use this table. Okay, all you need to do is just sum product with the probability information, then you get the I1. Easy, huh? Okay. So, and then this one is this is basically no, this one, the EMV is you already computed a while ago. Okay. So okay, practice. Okay, so practice. Can you calculate the EVPL PI? Yeah, can you calculate the EVPI? This one. Okay, I will give you time, no problem. I will pause the. When you want to share your screen.
Okay, sir.
Okay.
So
Okay.
first matrix is just the given, then same thing with how we calculate the regret. We take the maximum per column, and then we take EMV on the first matrix based on the given, and then EMV of the maximum payoff, the
Okay.
maximum payoff matrix. Then we get
That
I
is fine.
naught and I1.
Yes.
And then EVPI is just the difference or absolute difference between the two.
Right. Right. So I hope you understand the meaning of this value. 7.5. What is that?
As mentioned sir, earlier, it's the willingness to pay.
No, it's not just willingness to pay. This is the willingness to pay to get perfect information.
To get I1.
Yes.
Okay.
Okay. This is the willingness to pay to get your perfect information. That's why we call it EVPI, which is EV is the expected value of to get perfect information. Okay. So if you have a fortune teller that can tell you with certainty, 100% correct, okay, which state of nature will happen tomorrow, N1 or N2 or N3, okay, then this is the value that you are willing to pay for that fortune teller. That's the meaning of EVPI. Okay, so you can also calculate a while ago you already calculated the minimum expected opportunity loss, right?
Yes, sir.
Yeah, is that the same value?
Okay.
check the probability, should be the same.
0.2,
Probability is,
0.7, 7.5.
yes, 7.5, right? Right, so this one is exactly the same as the EVPI. Yes. So, nice.
Great, thank you, sir.
Yes, thank you. Yeah. So, how about the others? Is this clear or this is unclear? Option 3. Okay, so let me share my screen about the next slide. Yeah, the next slide is a little bit hard, so I will make it slow. Oh. It's good, yeah. Good. So I will share my screen and let's do the decision analysis. Yeah, you can follow this in model. A decision tree. Yeah. So the title is decision tree and risk analysis, but actually this contain also the value of information. Yeah. Okay. So we'll discuss first about decision tree. Okay. And then in this topic, we'll talk about decision tree is easy. Okay. The later one, when we talk about risk analysis here, especially the value of information, this is probably the hardest part there. Okay. And then sensitivity analysis, you already know. So this is easy part. Let's start. Okay. So we have discussed decision under risk. Okay, so all of this also still in the same umbrella, okay, of decision under risk. Okay, we discussed about using EMV or EV, and then maximum EV, and then minimum EOL. Yeah, so expected opportunity loss. Okay, so now we want to generalize this too, yeah, especially the EV. Okay, so we will use exactly the same as EV. Okay, but now you have sequence of decision, not just one decision. You have a sequence of decision. Yeah, so this is called decision strategy. Okay, so if you have only one decision, so easy, right? You can use that matrix. Okay, but if you have a sequence of decision, okay, so then you need to use a different tool. So this is called decision tree. Okay, so decision strategy is a strategy involving a sequence of decision. Okay, there is chance or outcomes. Okay, and then you want to find the optimal solution for decision problem. Okay, remember, yeah, a while ago we used decision payoff matrix. That one is only one decision. Okay, choose among these alternative under state of nature. But how if you have many of these matrices? And then they are sequential. Then you need a better tool. Okay, so this is what decision tree is about. Okay, decision tree is a graphical representation of decision problem. Okay, that show the consequential nature of decision-making process. Clear? Okay, the difference now is in here. Yeah? That is what is called sequence of decision. Okay, so how are we going to represent decision tree? Okay, so decision tree is something like this. Easy. Okay, so there are three types of nodes. Okay, so decision node, this one, the blue one, is decision node. Okay, so I will use square. Okay, so the branch of decision node are alternative, so big order or small order. Okay, so the branches of the decision node always alternative. Okay, now if you want to make decision in here, okay, you maximize the EV from all the branches later, yeah. So if you want to make decision in decision node, what you will do, you maximize the EV. Okay. The next one is called chance node. Yeah, lucky. So circle here is called chance node. Okay. So the branch of this circle or chance node is not alternative. Okay, they are state of nature. Okay, these are the state of nature. Okay, so remember, yeah, the branch of chance nodes is always state of nature. And then if you want to compute in here, what you will do is you sum the branch probability like this, and then multiply by the EV of this its value, yeah, its branch. So probability multiplied by the EV. In here, you maximize. In here, you calculate the EV. Okay? So, and then the third one is called the leaf node. So I don't have any symbol, yeah, because this is at the end anyway, right? So these are the leaf node. Okay, so basically this is the payoff or the outcome. Okay, so the value here is always the payoff or the outcomes. So if you want to calculate the EV, okay, you multiply, okay, this value with the probability. Yeah, the branch probability multiplied by the payoff. Yeah, so you will get the EV. Okay. So remember there are three kind of nodes in decision tree. Yeah, one is decision node, represented by decision square like this. The second is the chance node, okay, represented by circle, and then the last one is the leaf node. Yeah, I don't have any representation, but they are always at the end of the tree. Okay. So the next. So let's use this fruit store problem. So this is also in your assignment for today. Okay, so let's start here. Can you identify which one is decision node, which one is chance node, which one is payoff, which one is probability, which one is alternative, and which one is the state of nature? And of course, yeah. So which one is decision node? This one, yeah, the blue one. Okay. Which one is the chance node? The circle, yeah, yellow circle here. Which one is the payoff? In the leaf node here. Okay. These are the payoff. What is the probability? Here is the probability represent the state of nature, right? And then which one is the alternative? This one, yeah, big order or small order. Yeah. Which one is the state of nature here? High demand, low demand. Clear or not? Okay, so you probably understand already using this drawing. Yeah, this is the fruit store. Whether you will buy, you order big or you order small. Yeah, if high demand, okay, you will gain this one. Yeah, if low demand, you will lose money. Yeah, if you order small, if you have a high demand, then you lost little. Yeah, because this is loss of opportunity. Okay, minus 10 here is loss of opportunity. Yeah, and then small order, low demand. Okay, you still earn something. Okay, so here is the actual fruit store problem. Okay, so this is about the inventory of a fruit store. Of course, you can generalize this to any other example in transportation or in urban planning. Okay, so I just make it simple so that you can understand the concept. Okay, so imagine that you own a fruit store. Okay, if the demand is high, and then you order a lot of fruits for your store, then you will gain much profit, right? The demand is high, you order a lot, so you get a lot. So you are lucky, okay? But the demand is high, and then you order only little of fruit, okay? You lost opportunity, yeah, to sell. So, and then if the demand is low, but you order a lot, the fruit perishes. So you lost a lot. Okay, and if the demand is low and you only have little fruit, well, you still get little profit. Okay, so those numbers there represent exactly this. Yeah, the payoff here. Is this clear? Yeah. So now let's compare decision tree and payoff matrix. Okay, so for every payoff matrix, there is corresponding decision tree. So you can always create decision tree from payoff matrix. But the reverse is not true. Yeah, not all decision tree can be converted back to payoff matrix. Why? Why? Okay. In decision tree, okay, in this example, can you notice the probability here is all the same? High demand for small order and big order, all the same. Yeah, so notice the probability is the same for each state of nature. This is where you can create the payoff matrix, right? But what if the probability of high demand and is different for big order and small order? You can still do it in decision tree, but you cannot do it in payoff matrix. That's why, okay, payoff matrix is practically just a subset of decision tree. Is it clear or not? So now, can you convert decision tree here into payoff matrix? Can you create payoff matrix from this decision tree? Yeah. You can, because they are the same here. Yeah. And then this one also exactly the same, 0.4 and 0.4. Is it clear or not? If they're not the same, so you cannot convert into payoff matrix. Yeah. That is to answer here. Why? Okay. So can you identify if decision tree can be converted to payoff matrix? Yes, if the probability of the same state of nature are all the same. If they are not the same, so you cannot convert back. Okay, so say you have this decision tree, okay, then you can convert back into payoff matrix here. Okay, can you type this in your Excel? I will wait because this one is very long slide, okay, and then become very much complicated. So you type this first. Can you? Tell me when you are done, okay? I will wait. Just typing of this table. This table only. So if you calculate the EV or the EMV, how do you calculate? Get just additional in the right side here, right? So 0.6 multiplied by 100 plus 0.4 multiplied by minus 100. Yeah. So it done. Okay, done. Good. Okay, let's go to the steps to solve decision tree. Okay, so decision tree problem is to find the optimum decision alternative from decision tree. Okay, so how do you do that? Okay, number one, you compute the EV for each leaf. So you start from the leaf. Okay, so you start from the leaf and then you compute the expected value, EV. Okay, after that you go to the chance node and then you compute the EVs, yeah, for the chance nodes. After that you go to decision node, okay, you compute the maximum EV, okay, and then you identify the best decision. So easy steps, okay, so let's do it step by step, okay. So we start with the table a while ago that you made, right? Or this decision tree that you have. Okay. So what's the best decision alternative for the fruit store problem? Okay. So step one is to compute the EV, yeah, the expected value for each leaf. So we have 160%. So then EV is, yeah, you just multiply. So you get 60 minus 40, 6, and 20. Up to here, is this clear or not? Yeah. So remember a while ago, yeah, the leaf node here, the end of the value of leaf node is the payoff, yeah, the outcomes. Okay, and then what you will do, you multiply the branch probability and that payoff to get the EV, right? So exactly this one. Okay. Slow enough. Next. The second step, okay, you already get that EV, okay, which is 60 minus 40 minus 6 and 20. So the next step, we use this EV, okay, in the chance node. Yeah, in the chance node, you have 60% times 100, 40% times minus 100. So here, yeah. And then here, you have 60% minus 10 plus 40% times 50. Yeah, this comes from this value, right? Can you see? Okay, so you get EV, okay, 60 minus 40, okay. So then you use that information. Yeah. So practically you just add the two EV. Okay, you practically just add this two EV. Yeah, you just add this. Right. So 20 minus 6, you get 14. Yeah. This one 60 and minus 40, you get positive 20. Okay, the EV is propagate to the chance node. Okay. So next, what you will do? Okay, you get the expected value of this one. Yeah. So ordering many fruits. What is the big order EV? Okay, which is just this one, yeah, 20 and then 14. Up to here, is it clear or not? Okay. Okay, got that. Yeah. So, and then the next one, okay, now you have two EVs, yeah, 20 and 14. Which one is bigger? Right? So the next one is, okay, remember, yeah, in the chance node, the branches are the state of nature. So you need to sum of the probability multiplied by the EV. So to get the EV itself, okay, the new EV. So the next one is to compute the maximum EV, because now you have decision node, okay, 20 and 14. Which one? Of course, maximum between 20 and 14, which is 20. Okay, so then you identify the best decision, which is just make it bold here. This is the best decision. Clear? Very easy. Yeah, if you have just one payoff matrix, this is super easy. Yeah, you just propagate, yeah, from the leaf to the chance node and then to the decision node and then identify the decision. Yeah. So remember, in decision node, yeah, the branches are alternative. Okay, and then what you will do there, you maximize the EV from all the branches. Yeah, this is the optimum decision. Yeah, you get 20 here. So the decision is to use big order. Yeah. So how are we going to do it in matrix? Yeah. Yeah. If you do it in matrix, yeah, this is the actual value that you're supposed to type, right? So, and then if you want to calculate the EV, okay, you multiply this 0.6 with 100, okay, you will get this one, right? 60. Yeah. So these are the value a while ago in the chance node. Okay. And then this is the value in the decision node. Okay, and then this is the actual decision that you do, okay, by maximizing that sum. Okay, so far it's the same, like decision under risk, isn't it? Huh? What's the hardest part here? Nothing. Yeah, up to here, no problem. Easy, this one. Okay, so what will happen if you put the probability 0.5 and 0.5? What will happen if you change this? Not 0.6, but now it becomes 0.5, and this is also 0.5. What will happen?
The maximum EV
Zero,
goes in order.
right? You get
Zero
zero
for
and
the
zero, right? You get 0 and 0, right? So you cannot decide because they are equal. Yeah. So if this is one of the weakness of using expected value. In this case, you can use utility later. EV is 0.2. No, 0 and 0. If you use 0.5 and 0.5, you're supposed to get 0 and 0, right? Not 0 and 20, yeah. Okay, up to here, is this clear or not? So up to here is easy. So the next topic is super hard. So listen carefully, okay? So let's go to the risk analysis. Okay. So risk analysis is the study of possible payoff and probabilities associated with decision alternative or decision strategy. Okay, so meaning you can use either one payoff matrix or you can have many payoff matrix. So you can have decision strategy. When we say decision strategy means you have a sequence of decision. Okay, so in this topic, let's discuss about risk profile, and then we will again about the value of information. You remember we already discussed EVPI a while ago. Okay, now we will enhance it into EVSI. Yeah, so the value of information. Yeah, this is just ideal. Okay, not real. This is the reality. This is the reality. Okay, and then we discuss a little bit about sensitivity analysis. Okay. Okay, what is risk profile? Okay, let's go to the first part. Yeah, what is risk profile? So risk profile, yeah, is a chart like this. Okay, risk profile is basically probability distribution. Okay, something like this also. Okay, this is risk profile represent probability distribution. Yeah, so remember this, yeah, of the possible payoff associated with the selected decision alternative or decision strategy. Okay, so what we will do is you compare. Okay, this is the risk profile of the fruit store problem. Okay, this is without study, this is with study. Okay, so it will change from here to here. Okay, so how do you get the risk profile? We get it from the optimum decision. Okay, so a while ago you maximize, right? You maximize the EV. Yeah. Then the probability associated with the optimum decision, which is the maximum EV, that is the one that you plot. Yeah. Later, we also discuss about marketing study, yeah, or consultation. Yeah. So here it is to get this, the first risk profile. Yeah. The first risk profile is like this. How do you get it? Easy. Yeah. So remember, risk profile is based on optimum decision. Okay. And then you get the probability. Okay. What is the optimum decision here? Okay. The optimum decision is a while ago, big order, right? What is the probability? Oh, you have high demand and low demand. Okay. And what is the value of high demand? 100. Okay. What is the probability of low demand? Minus 100. Oh, these two numbers, or four numbers basically, and two tuple, you just plot it. You see here, 40%, yeah, this one is 40%, okay, of minus 100. And you see, this is from here. Okay, this one is 60% of 100. So this is come from here. This clear or not? Yeah. So risk profile is just a plot of probability and the payoff. You see, yeah? Which probability? Not all probability, only the probability related to this optimum decision. Yeah. Okay, this one we don't use. Yeah. This one only check. Yeah, this one no. Okay. Can you practice first? Okay. This one. Okay. Can you create your own payoff table, okay, with probability for each state of nature? Okay, at least you have two alternative, two state of nature, and then can you make decision based on maximum EV? And then can you draw the decision tree of that payoff table? And then can you create the risk profile? Okay, I will stop the recording and then wait for you to do this. Okay. Once you finish, you share your screen, yeah?
How to generate again
How to generate what?
the risk profile?
The risk
Risk
profile.
profile, yes.
Okay, so if you want to generate the risk profile, okay, you get the maximum EV, okay, and then you put that decision. So I will show you in a moment. This one. So you get the probability and then what is the best decision payoff, and then you can put that. So in the slide here, a while ago, okay, we have this one. Can you see? You create the best decision, okay, with this value, okay, maximum between 20 and 14, so become 20. Okay, now we put back into the actual value here. Okay, so the actual value is big order, right? And then what is the value of the probability and the payoff for that decision. Okay, so in this example, okay, because I selected big order, so the probability is 0.6 and 0.4, and then the payoff is 100 and minus 100. So in that case, I will just put that information, okay, these four numbers, okay, into this kind of table. Can you see this? This one. Okay, and then I plot. So here, is it clear or not?
Thank you, sir.
So can you share your screen so that I know what's going on? No, not even one person want to share screen. What's the problem?
Sir, I'm still not yet done creating the risk profile, but I can share my initial
Oh, sure. Oh,
computation. I'll just send the picture because I'm having a hard time sharing using the laptop.
okay. Let me check. Oh, Kenneth, you did it. Okay. Okay. Pearl also. Oh, wow, very big number. So what's the probability? In this case, you put 0.7 and 0.3. Okay. And then what is the value for that probability? It is 500,000 and 200,000. Is that million or thousand? Oh, 200 minus 200,000 and 500,000 per. Okay.
Sir, that is the net profit in dollars. So I use the probability for the stable soil and unstable soil po.
So can you draw the risk profile? The risk profile from the probability, okay, and then the one that you get the best decision, the leaf nodes and the payoff of best decision. Yes, Franz, Julian. You want to share your screen?
I can use the computer. I think I'll just screenshot this.
Okay. is unclear.
Yeah, it's not clear. I don't know why it's not focusing.
Yeah. Okay, you just send them.
Okay, I'll just send.
Okay. So up to this point, nothing hard at all. Okay. Right. It's basically just getting the EMV, the same like probability. Okay. So let's go to the next topic. Okay, this is the hard part. Okay, so listen carefully. The topic is called value of information. Okay. Can you see the slide? Okay, Lei, you can make it. Very good. Yeah. Okay. So, before that, okay, this can be discussion, and rhetorical questions. Okay, why do government and company hire consultant? Okay, why do we conduct feasibility study? Why do we build database management system? Why do we build prototype? And why do we conduct experiment or simulation before the real project? Okay, so the actual question is how much, okay, that investigation worth to study, okay, how much is the real value of feasibility study? How much is the value of information containing in that database software? Okay, so if we invest in building this prototype, okay, how much value we will gain? So this is a technique to compute this kind of value. So are you interested? Right? So how much you should pay your consultant? Okay, that's okay. How much you should pay your software? How much you should pay your simulation or your experiment? So we can quantify this, based on decision under risk. So interesting enough. Okay, so why we value, why we learn about value of information, yeah. So how much important information we would like to gain before we spend the time and effort and money to decide, to hire a consultant, to study, purchase piece of software, or build a model, prototype, or perform experiment, right? So practically, there is fundamental need for human for information. Why? Because information will make us create better decision. Okay, so this is what is WTP, willingness to pay. People are willing to pay good money, to process some information so that it will help us to make better decision. Okay, so this is come back to the fortune teller a while ago. Okay, so we start with perfect information. What is perfect information again? Knowing with certainty in advance what event will occur. Okay, so the question is, how much are you willing to pay to obtain this perfect information? Okay, so that one is called EVPI, right? We already learned that a while ago. So EVPI is the absolute value of information with and without perfect information. So I hope you remember this. We just discussed this several minutes ago, right? So today, during the EOL work, very good. Okay. So again, yeah. So the expected value of perfect information, so we call this EVPI. Okay. Okay, this is the amount of money you are willing to pay for obtaining the perfect information. Yeah. How to compute this? You compute by subtracting the value, okay, of the alternative with perfect information, I1, and then from the value without perfect information, I0. We already learned that also. What is the I0? I0 is practically just maximum EV. Okay. What is the I1? I1, okay, similar to regret a while ago, you maximize first and then multiply by the probability. So you get I1. You practiced that a while ago. So you already got the EVPI. Okay. So let's do this for the fruit seller problem. Okay. So that you can get more examples. Okay, so let's continue from the fruit store problem. Okay, we get the maximum between 20 and 14, right? So this is basically the EMV. So this is the I0. Okay, we have decided to select big order without any information about the state of nature which will happen. Okay, so without any study, without any knowledge which demand will be high or low tomorrow. So you just decide big order because the EV is the highest in here. So without study, this is the I0. Okay. So say, come back to this decision tree. Okay, say a fortune teller is telling you, okay, that the demand will be high tomorrow. Okay, what will be your decision? Look at this decision tree. Tomorrow will be high. So here, high demand. This is also high demand, right? Okay, what is the value? So there are two possibilities in this case. So you have 100 and minus 10. Okay, both have probability of 0.6. So you multiply, right? So you want to maximize between the value of 100 and minus 10. Okay, so thus you will select 100. Okay, why? Because 100 multiplied by 0.6 compared to minus 10 multiplied by 0.6. This is bigger. So you select big order. Okay, so the probability is still there because we are not sure. We are not 100%. Okay, so between these two, between 100 and minus 10, which one is the maximum? 100. Okay, that's what you will use. Okay, so now what is your decision if you know for sure that tomorrow the demand will be low? The same. So you know this one, tomorrow is this one. Okay, low demand have two value, okay, minus 150. Okay, so in that case you will select, okay, maximum with this one, 50. Okay, so but even though you know for sure the probability is still there with this one, 0.4. So you multiply, okay, 50 with 0.4. Okay, so now you combine these two value. Okay, so 0.6 multiplied by 100 and minus 10, and then 0.4 multiplied by the maximum of minus 150, right? Can you see this is low demand, low demand. Now this is high demand and high demand. Okay, then you get the E1 of 80. I1 of 80 and I0 of 20. So the EVPI is 80 minus 20, which is 60. Yeah. So with this, okay, this is the maximum willingness to pay, yeah, to get such certainty for the information. Okay, this is the amount, okay, you are willing to pay for the fortune teller or consultant or market research, okay, for any value, okay, below 60 is fine. Okay, maximum you are willing to pay is 60. Yeah, if the prediction is 100% reliable. Okay, that's why we call it perfect information. The P here represents perfect information. 100% reliable. Okay. Okay. So you can, do you understand or you have any question here? Yeah. So you are still doing the risk profile. Pay attention to this first because this is your assignment letter also. Okay. So you can continue with your own decision analysis, yeah, to compute your EVPI. Yeah. How much are you willing to pay, yeah, for the perfect information to make the state of nature, yeah, from uncertain become certain. Okay. Later you can do this. Okay. Okay. So let's do what is called, we hire a consultant. Yeah. So let's do a market study. Okay, market study. Yeah. Why we do market study? Because perfect information is nearly impossible to find. Okay, it's not realistic. So on the other hand, imperfect information is often available, and this is more useful than perfect information. Okay, you can use research, you can do market study, you can hire consultant, you can do experiment. Okay, you can create model, and you can develop the software to improve, okay, your imperfect, yeah, information. From no information become imperfect information. Hopefully, the imperfect information is going toward perfect information. Okay, so remember, the study can be favorable or unfavorable, right? So the meaning of favorable here means reliable or correct. Okay, and then the study can be unfavorable. That means the study can be incorrect, not reliable. Okay, but we are dealing with probabilities here. Okay, now this is the hard part. We need to review. To compute this, you need to understand this jargon. Many jargon. Prior, conditional probability, posterior, likelihood, and base rule. Yeah, I will discuss this in a moment. So I hope you pay attention to this. Okay. So here it is. So you have this table. Say you have this gain table. Okay. So the probability of the state of nature here, okay, this is called prior probability. Okay, so this is called prior probability. So P, prior probability of the state of nature S1 is P1. Prior probability of the state of nature of S2 is P2, and so on. Of course, the sum of probability must be 1. Yeah. Okay. Clear, yeah? This is just the name, okay? Prior probability is this one, the one that you assign, yeah, in the state of nature. Okay, next, okay, this is called conditional probability. Okay, so look at this. Now you have the study. Okay, the study can be favorable or unfavorable. Look at this. A while ago, you have the state of nature here, S1 up to Sn. Okay, when you conduct the study, can be favorable or unfavorable. So the state of nature is now in the row. Okay. Now, the probability of having the state of nature S1, okay, and then that study is unfavorable or unfavorable. So this is called conditional probability, yeah, which is called likelihood. What is likelihood? It is a conditional probability that the study either favorable, correct, or unfavorable, incorrect, for the given state of nature. Yeah. So this one we assume to be known. Of course, the sum is 1. Okay. For each state of nature, the sum is 1. Okay. Second jargon, likelihood. What is likelihood? Given the state of nature, what is the probability whether the study is favorable or unfavorable? Clear? Now we reverse. Okay. Look at this, favorable given as 1. Yeah. Now we reverse. When we reverse the probability, this is called posterior. Yeah. This is called posterior. This is the one that we want to know. That the study can be favorable or unfavorable with some probability. So what is posterior probability? Given that the study is already known to be favorable or unfavorable, okay, what is the conditional probability of the state of nature? Yeah, so given the whether the study is correct or incorrect, what is the probability of state of nature? Yeah, can you see the this is reverse. Yeah, favorable first, and then given the S1, what is the probability of favorable in likelihood? In posterior is the other way around. You know that this is already favorable. What is the state of nature? Okay. So the next jargon is called joint probability. So joint probability is the intersection. Okay. This is the probability that actually the probability of favorable or unfavorable. Okay. How do you get that? That is computing by the prior multiplied by the, what is this? This is the likelihood. Yeah. So can you see this? This is the likelihood. Okay. So the prior multiplied by the likelihood, you will get what is the probability of favorable or unfavorable. Okay. The last jargon here is called Bayes theorem. Yeah. So to compute the posterior, okay, you get the likelihood multiplied by the prior, and then you sum all of that, okay, so that you will get the actual posterior. Okay. So here, this is the formula of Bayes theorem. Okay. So we will put it into favorable or unfavorable study. Okay. So now you have the prior state of nature, and then you have the likelihood, okay, whether this state of nature is favorable or unfavorable. Okay. and then you divide by the sum of that, the same thing, you will get this posterior probability. Okay, this is the one that you are looking for. The posterior is the one that you are looking for. Okay, so let's do the exact numbers in the fruit store problem. Okay, so that you can be familiar with this. Okay, so now I will give you the likelihood probability. So this is given. Okay, for the fruit store problem, so this is given. So remember, in the fruit store problem, we have either high demand or low demand, right? With 60 and 40% probability. Okay, now we have, okay, the likelihood. The likelihood is given. Okay, so the likelihood of market study, whether it is correct or incorrect, right? So if the state of nature is high demand, okay, this market study, this consultant, okay, have probability of 90% correct. Okay, that means 10% incorrect, right? So this consultant, okay, will tell low demand, okay, so the probability to be correct is only 20%. So that means the incorrect is 80%. So this is given, okay? Or you can decide on your own for your case. Is that okay? And then what you will do, okay? Given the likelihood, okay, and the prior, you already know the prior, right? This is the prior number, 0.6, 0.4. This is the, remember, prior is the probability of the state of nature. And you know the likelihood value here. This table is the likelihood value. Okay. So then what you will do, we'll put this here. Okay. Given this value, okay, we will compute this joint probability. Given the prior and the likelihood, remember, prior, okay, multiply by the likelihood, yeah. Okay, so this is the value that we have here. Okay, for example, okay, 60% multiplied by 0.9, so I get 0.54. Okay, 60 multiplied by 0.1, so I get 0.06. So this is called, this table is called joint probability. Is it clear or not? Okay, so this is the joint probability, okay, that high demand and the market study is correct. Yeah, high demand and the market study is incorrect. Yeah, low demand, the market study is correct and incorrect. So you have the one in pink here. Okay, these are the joint probability. Okay, then you can calculate, what is the probability that the study is correct. Okay, in here you get the sum with the 62%. Okay, this is the probability that the market study is correct. Okay, and this we have 38% that the market study is incorrect. Oh, not so high, right? So based on this likelihood that you said, okay, you know, when you hire this consultant to do market study, okay, the probability of having the study is correct is only 62%, not high, yeah? Okay. Okay, then we can calculate, because you already know the joint probability, the likelihood, and the prior, so you can calculate the last one with this posterior, yeah, using what? Using Bayes theorem, yeah. So this one. So, okay. So remember I copy here, the one in pink here, I copy in this table. Okay. So then we can calculate the posterior probability. Yeah. So how to compute low demand and the study is incorrect. How to compute high demand, the study is incorrect, high demand correct, and low demand correct. Yeah, these are the computation. Yeah. So low demand incorrect, that means low demand. Okay. This one is, what is this? This is incorrect low demand. So here, yeah, 0.8, right? Okay. And then here, 0.32. Yeah. So this is the joint probability. Yeah. So you get the 0.32 multiplied by the actual probability of low demand. Okay. 0.4. Okay. So you get this value. Okay. Once you have these 4 probability, okay, you put them into table. Yeah. So this is called posterior probability. So I have 0.84, 0.16, 0.87, and 13. Yeah. So this is the table that we get as posterior. Yeah. This value comes from this joint probability multiplied by the prior. Yeah. This is the likelihood. So we don't use this one. So you need to compute based on the joint probability. Okay. Once you do that, so we get this probability of market study, which is the posterior. Okay. So with this posterior, now we can draw the decision tree. Wow. So this is the actual decision tree. You see, we have sequential decision. Yeah. So first is whether you need to do study or no study. Yeah. Yeah. This is the no study is the original decision tree. Okay. And then the bottom here is come from the posterior. Yeah. Yeah. And can you see this? 87, 13. Yeah, this one come from here. So 87, 13. This one is 16, 84. It's come from these numbers. Okay. And correct and incorrect come from earlier. Yeah. What is that? This one. Yeah. 62 and 38. Okay. Probability of correct and incorrect is 32 and 68 there. Okay. So we have those values. So we create this expanded decision tree. Okay. Now you have sequential decision. First, you want to study or you don't want to study. And then when you conduct the study, you need to, in here, there is a chance. Yeah? If you do market study, there is a chance to be correct or incorrect. And then these are the 2 decisions, yeah, big order or small order. Okay. But now you have different probability. Okay. So you know how to compute this. Okay. This is your assignment later. The answer is already here, but I want you to do it so that you can understand this. Yeah. So once you have this, what you will do, okay, you do exactly the same as the usual decision tree a while ago. Yeah. So first you do in the EV in the leaf node. Yeah. You get the EV in the leaf node. Okay, each of them. After that, what you will do, this is the same as computation, yeah, of correct and incorrect market study. So I put it into table. You get exactly the same value. Okay, so I just separate 2, yeah, correct market study and incorrect market study. Yeah, this is for EV of the bottom part here. Okay. And then what we will do, we check, yeah. So if no study, a while ago we already get this value with this big order. Okay. And then if you use market study and the value is correct, okay, you will choose big order. And if the value is incorrect, you will select small order. Okay. With certain probability. Okay. And then we continue this. Okay. Okay. We continue this. Then you will have, if the market study is correct, okay, you will select big order. Okay. If the market study is incorrect, you will select small order. Yeah. Look at this number. Yeah. This is the one that we will use, yeah, in the profile, risk profile. Okay. So eventually, of course, you compare no study or market study. Yeah. So you will get 20, 46, and 15. Yeah. So in here, 46 and 15, you will combine, become 61. Okay. So then this is higher. Yeah. Maximum EV is between 20 and 61. So the decision is to do market study. Yeah, the decision is to do market study. So what is the optimal decision? Yeah, this one. Yeah. So the point is this. Yeah. Despite the market study is very far from perfect, right? It's just 60 something percent. Yeah. Okay. But it is still optimal decision to choose that. Okay. Then the next question is, how are we going to get the role of information from the market study? How much are you willing to pay for that market study that is not perfect at all? Okay. So that point, okay, we will use what is called the new concept. This is called EVSI. Yeah. So instead of EV of the perfect information, now we call it sample information. Yeah. So let's call this thing understudy as sample information. This is not my jargon, okay? This is already well known. So I don't create this. You can search in Google. Everyone knows about this, okay? So even AI will know about this, okay? So using similar method to perfect information, we can compute the expected value, okay, of the study. So this is called sample information, okay, about the state of nature, okay, about the expected value without and with, yeah, sample information. So then we can compute the difference, and then we will get the expected value of sample information. Okay, how to do that? So here it is. Okay, so you have the probability, okay, P0 and 1 minus P0. Okay, this is without, okay, this is without sample information. This is with sample information. So the computation is exactly the same, okay, but now instead of using probability prior, what do you use here? Okay, what do you use here? This is the posterior. Okay, look at this value. Okay, this is actually the posterior. Okay, where is the posterior? Yeah, this one. So you will get the actual value, this one, favorable, this one. Sj and then given favorable. So this is called posterior probability. Okay, this is the one that you will use here. Yeah. So you are using posterior probability to compute the EVSI, not the prior. If you use prior, that will become EVPI, which is expected value of perfect information. Yeah. So now you need to compute the posterior probability. Okay, then you will get the actual value of this sample information. And then you can, once you get the EVSI, you can calculate the efficiency of the study. Yeah, efficiency of sample information is just delta SI divided by the perfect information. Yeah, so EVSI divided by EVPI is called efficiency of the study. Yeah, because we know the actual EVPI, so we can calculate that efficiency. Okay, so for our case here, okay, so we have 20 and 61, right? So the EVSI is just minus of this, so you get 41%. Okay, the EVPI we already computed a while ago, so then we can get the value to be 69%. Yeah. So once you have that, okay, then you can get the risk profile. Yeah. Okay. How do you get the risk profile? This one, yeah. A while ago, without information, we have these two numbers, right? So now with market study, okay, with market study, now you have this number, yeah. So with the market study, you have either correct or incorrect, okay, the one in bold here, and then you get this probability, okay, the one in the bold line, okay. So 87, 100, 13% minus 100, 16% minus 10, and 84% 50. Yeah. Then all of this you plot, you will get the risk profile of market study. Okay. Then you can start to see the change. Yeah. So without study, you practically you have only this risk profile. Okay. With market study, that's why you get a better result, because now you are more distributed. Yeah, the risk profile of market study is actually more distributed instead of here. So now you get so instead of 60% here, can you compare? It now become higher in the positive side. Okay. So at least now you know, using this, okay, how much are you willing to pay for your consultant? Yeah, with this here, 41.4. Yeah, and you know the consultant efficiency is just 69%. Okay. Up to here, is there any question? Is it clear or not? Am I too fast? I know this is hard. Okay, this last part is hard. Oh, you understood. Very good. Okay. Yeah, okay. So anyway, when you do your assignment, then you will understood better. Yeah, you will understand this better when you do the assignment. Okay. But the big picture, you understand or not? Okay. The big picture is through risk analysis. Okay. you know how to quantify the probability. It is basically the posterior here, okay? And you know how to quantify how much are you willing to pay for your consultant, and how much is the efficiency of your consultant. So many of you are government agencies working in the government, and many of you also working in the consultant. So this technique is important for you or not? Yes, I will surely upload this video. I hope the recording is fine. So good. Yeah. Okay. Yeah, I understand this is hard. Okay. That's why last week I asked you read first before the class. Remember. Okay. Because this is really hard. Okay. Okay. But important for you or not? This is your bread and butter, isn't it?
Yeah, very important.
Yes,
sir.
it's important. You're a
Very
technical
important, sir.
person.
Yes. Yeah.
I agree with Sir.
Agree. Yeah. This is your bread
Yeah,
and
agree.
butter.
Yes, sir. Yes, sir.
Right. So you need to know how to compute this because this is really your bread and butter. Yeah? Whether you're in the government, whether you're in the consultant, right? Okay. So now you know how to compute. Okay. Now you know how to compute, quantify this into money. Of course, a lot of assumption I understand. So, but this is you need to do. Okay. So the last part. Okay, do I still share? Okay. The last part is just sensitivity analysis. Yeah. So you can just do sensitivity analysis is just using data table. You know already. Okay. So some of you did not do the assignment for the Horowitz. So please do it so that you know how to do. And this one is now the same thing, but now you have more values in the data table. Yeah. So you just copy this high demand, okay, and low demand, okay, and then you can just do the sensitivity analysis using data table, okay, and then once you do that, you just plot. Yeah. So that's it. Okay, so with this, thank you very much for today.
Yeah, thank you very much, Doc.
Yes,
All right.
right. So
Thank you, sir.
I hope this is useful.
Thank you, sir.
Thank you, sir. Happy
Useful naman, sir.
Have a nice
Thank you,
day.
sir.
Bye.
Now you have 2 assignment, yeah. Don't forget.
Yeah,
Thank
noted,
you,
sir.
Thank you, sir.
Okay. Bye.
Bye-bye.